Hi, I'm Josh Borrow. I'm a PhD student in astronomy, and I'm going to show you today how to use matplotlib style sheets to take a basic Python plot like the one that you see on the left and turn it into a journal-ready figure like the one that you see on the right. These figures are in the monthly notices of the Royal Astronomical Society template, or MNRAS as many astronomers call it. And what you see is that it's in this classic two-column format. These papers are generated using Latex. And the default Python setup that you see in the plot on the left produces raster figures. So that means we can't zoom in and out of them very easily without losing quality. Whereas the ones that we have on the right are vector figures, so we can zoom in and out as much as we like. The one on the left has a bunch of extra white space around the edge that we don't need because that's already in the template. There's already spacing between the columns for us, and we don't need extra padding around the figure. We're just wasting space there. Well, we could really blow up that figure and have our data be displayed much more prominently. We've changed to the same font that is used in the journal. In this case, that's Times, but there are other appropriate fonts for you to use that are exactly the same as other journals. And another final trick that we've done is we've moved the tick marks inside the plot so that it's much easier to stretch it even further so that our data is displayed even more prominently. We'll get into how to do this next. It's really easy. It's just 10 lines of Python. Okay, so we're ready now to take a look at how to improve this figure on the right. So in the introduction, I said that it was difficult to zoom into this without getting pixelated. So what I see a lot of people doing is saving their plots as PNGs. So this is a raster format, which essentially means that instead of saving the data points as like circles and lines, what you're doing is you're saving a grid of pixels. Now that in principle isn't necessarily a bad thing to do, right? If you're trying to save an image and make it look exactly the same on every machine, then that's great. But if you're trying to have just a figure that where people can inspect the data very carefully, then it's not as nice to have a set of pixels as it is to have vector elements. And you'll see slightly more what I mean when we change this to a PDF figure later on. The other problem is that the default resolution that Python saves these images as is quite low. So it's 72 dpi. And what that means is that there's 72 pixels per inch on a piece of paper. Now, even a cheap printer these days prints at 600 dpi. So we're not even using it close to what the, even a basic printer can do. And the reason for that is that the more resolution you have, the bigger the image is on disk, right? And so if you saved every plot at 2400 dpi, it would just waste up all of your hard drive space. Now, the neat thing about the vector graphics is if they're things like this, where it's like little error bar plots, a vector plot actually takes up less space than even this very low resolution figure. And so how do we do that? Well, the first thing that we'll do is we'll look at the setup that we have here. So this is a LaTeX document. So as I said, this is the MNRAS template. I've put in some basic filler text, and I've extracted the bit that we need to think about into just a very simple text file. So here we have the section, which is an introduction. This ellipsum here is just a macro that puts in the filler text. And then we have the classic begin figure centering. What this does is it puts the plot in the center of the column. That helps if your plot isn't exactly the same width as the column. But what a lot of people do is they do change that so that in the include graphics, there's these little square brackets and you can do width equals backward slash column width. We're actually going to take this out later, but we'll leave it in for now. And then myfigure.png. Then you have your caption and some label, and then end figure and some more filler text. So here's the text file. The Python file that produces the plot is again very simple. So it's just import pyplot as plt from random, import random and seed. So that's just so that I can generate the points so that they look like they're something and not just straight lines. Then we create our figure and axis objects, and then we loop over two simulation data sets, plot them as error bars. So X, Y, Y error bar. The marker that we want to use, don't want a line here, we want to plot them as points, and then a label for each simulation. Then we set some labels, which is these set X label and set Y label commands. And then finally, we add a legend, which we see here in the lower left. And finally, we save the figure as a PNG. So the first thing I'm going to do is I'm just going to turn this PNG into a PDF. So I'll save that. And then here in the text document as well, we need to change this to PDF. All we're doing here is changing the file extension, but that doesn't just change the letters after the file, it changes what type of file it is. So PNG is a raster format and PDF is a vector format. And so what we'll do is I'll just compile it. And so what you can see here is when I zoom in, it's not pixelated at all, and that's because what we've done here is we've actually saved the data as a section of circles and lines and so on, right, instead of as pixels. And so this is just quite nice because it means that when someone wants to zoom in and inspect your plot a bit more, then it will, they can do that very easily. And also if someone prints it out, it will kind of adapt to their printer rather than looking pixelated on some printers and so on. And this is just quite a nice little feature. Okay, so how are we going to go about changing the look of this plot? Well, we're not actually going to change any of this Python code at all. What we're going to do is we're going to use a matplotlib style sheet. So in the same folder as this plot.py, I have a file called stylesheet.mplstyle. Now, at the moment, it's got nothing in it, right? But don't worry, we're going to fill it up. So to include this style sheet, it's similar to a CSS style sheet if you've ever used that. All we need to do is at the top of our file, do plt.style.use and then the name of our file, stylesheets.mplstyle. There are a number of built-in style sheets that you can look up. I'll include those in the documentation below this video. But we're going to build our own today that works just for MNRAS. Okay, so the first thing that we're going to do is we're going to change the font. So here the font is Deja Vu Sans, and that's just the default matplotlib font. But we can change the font size and the font family and the math font. So what we're going to do is we're going to set the font size and options. So you can put comments in this MPL style file with a hash, just like as if it was Python. And we'll do font.size 8. And then we'll do font.family STIXGeneral. So this may seem a bit of a weird name, but this is just the kind of internal name for a font that looks very, very similar to Times, which is what the font in this journal template is. And then we'll use mathtext.fontset, and then that's STIX, all lowercase. Okay, so let's save this. Let's save the plot, and let's just save the introduction.text again, just for good luck. And so all we've done here, right, is we've included this style sheet in the Python plot, and we've put some very basic information in that style sheet. So let's run the compilation again. And this also regenerates the plot, right? So in this bash script, there is Python plot.py. And you'll see we've changed the font to be Times-ish. It's not exactly the Times font, but it looks very, very close. And the main problem now is that the font's really small. You notice here that I set the font size to 8. Now, why did I do that? Well, that's because the actual font size in point, in like Microsoft Word or something, you go down and you select like 8-point font or 12-point font. That's actually 8 for the caption size in this figure template, but it looks very small. Now, why is that? Well, this really comes back to, in our text file, we have this, in the include graphics, we have width equals /column width. What that's doing is that's stretching this plot to fit exactly the width of the column. Now, stretching it to fit the width of the column isn't necessarily a bad thing to do, right? But let's just remove this for now and see what happens, right? So now just say include graphics myfigure.pdf. And what we'll do is we'll run the compilation again. Now, obviously the plot is far too big, right? But you'll notice that the text size is right. So this text matches this text in terms of size. It's just that now the plot is too big. And so the reasoning for this is that the default Python plot width is something like 5 or 6 inches by 4 or 5 inches. Don't exactly remember what it is, but if I go and measure with a ruler what the width of these columns are, they're actually 3.3 inches. So maybe we should just make our plot as 3.3 inches, and that's really easy to do in our style sheet. So what we can do is we can set the figure size for MNRAS. So for MNRAS, like I said, the width is exactly 3.3 inches, and we can set the figure size to that, right? So figure.figsize. You may have used this as an argument to the fig.subplots or something like that previously. This will just set the width to 3.3, that's the first, and then the height, let's just set that to 3. Okay, so we've saved that, and now let's compile again. And so you see, we've resized the figure so that it fits quite nicely within our template. Now, this is really just a coincidence in some ways, right? So we've put in a PDF that is exactly 3.3 inches wide into a column that's exactly 3.3 inches wide. So instead of stretching things to fit, we've just actually basically come with a ruler and said, oh, well, this figure should actually just be this size and should fit in this exact column in this exact way. And that to me is quite nice. Now, one thing here is that we do have a lot of padding around the figure. And so you may be tempted to change this fig size to, let's just say, like 3.6 inches or something, right? And now if I compile, then, oh, look, it fits quite nicely with the edge of the column here. But we're undoing all of that work that we did, right? So we can, in matplotlib, quite nicely change the edge boundaries so that we remove this padding. Instead of having to uncorrect the padding that matplotlib puts in for us, why don't we just put in the padding that we want? And because this is inside a PDF document where the padding is already set for us, then we don't actually need any padding. If we were looking at this plot printed out on a piece of paper, we wouldn't want it to be right up to the edges of the piece of paper, but because we're including this in another document, we don't need any of that padding. And to get rid of that padding is really quite easy. It's just some more lines, as you would expect in our matplotlib style sheet. There are a couple of ways that you can do this, but we're going to use constrained layout. Now, constrained layout is a new piece of the matplotlib toolkit. It's a bit like tight layout, where it resizes your figure and subfigures very, very tightly and nicely so that they all fit together and look quite nice. And you'll see what I mean by that. Now, this does break down when you have close to 64 subfigures in one figure or axes in one figure. So if you get there, then you'll have to reconsider some of this, and there's some documentation that I'll again put in the description down below, but you don't need to worry about that if you're just doing basic plotting like this. So let's just put in the lines that we need. Figure.constrainedLayout.use true. So that turns it on automatically for every figure. And then we have a bunch more lines like this. We have 4 more lines, and this is hpad. And let's set this to 0.05. So this is the padding between the edge in the horizontal direction. And then we have wpad, which is the waist padding, which I think is up and down. And let's just also set that to a small number. Setting them to 0 can cause some issues, so we just set it to a very small number so that the padding is minimal. And then H space, this is the space in between plots. So if you have a multi-axis figure, this is the space in between horizontal plots, and then W space is the same but in the other direction. Okay, so now we've added these lines, removing the padding. Let's do the compilation again. And you see we've stretched to fill the full amount of space that's available to us by the journal. Now, if I infringed on this center column line, they would be quite rightfully angry, right? Because that would look quite silly. and then I'm cheating them, right? Because they say you have 20 pages or whatever to write your paper in. You can't go outside of the bounds, but what we've done here is we've maximized the size of the figure that our data can take up. And that's giving our data the most room to breathe. The final piece of this is to change these tick marks inwards. So that's just another couple of lines in this style sheet. So xtick.direction in, put a comment there. Maybe we'll put a nice little comment here. Change ticks to face in instead of out. ytick.direction. We'll face those in as well. And again, we just go back and we compile. Of course, if you were doing these separately, you'd have to remake the plot and then recompile your paper. But there we go. We've changed the ticks to face inwards, and you saw that it just moved slightly. Just gave our data a little bit more room to breathe. What we're trying to do here is maximize the amount of the piece of paper that your data takes up and minimize the amount that padding takes up, because padding doesn't help us in any way. Okay. Now, the final thing that we can do is change the colors. So the default set of colors in matplotlib are these blues, these oranges, and then it goes greens and reds. Now, these are all quite nice colors and they look quite nice on your plots. The problem is that they don't actually change luminance very much. Now, what do I mean by that? Well, if I print all of these plots out on a piece of paper with a black and white printer, then they all have about the same brightness and they're quite difficult to distinguish. And you could very well argue that not very many people have black and white printers anymore, but quite a number of people do suffer from color blindness. And it can be quite difficult for them to tell the difference between two shades that are quite close. Now, different forms of color blindness work differently, but as well as helping people with color blindness, we can add a little bit of flair to our work by choosing colors. Now, choosing these colors, I would say if you're going to put them in a journal article, you should use some colors that somebody who knows about this kind of science has come up with, right? So people who are aware of the needs of people with color blindness issues. And there's some resources in the description to do that. And so the colors that we're going to use here are from a site called Paul Toll's Notes, and it's the vibrant color set. And this is quite a nice base set to start with. It isn't just the basic matplotlib one that you see in every paper ever. And as a bonus, like I said, they're better for people with color blindness. So I'm just going to copy and paste these instead of typing them in because I don't remember hex codes. I don't think anyone would ever expect anybody to remember hex codes. So the way that we do this is we set axes.propCycle to cycler, and then in the first argument, so this is a function, what's an object? The first is the string color, and then we have a list of the colors that we're going to use. And these are just hex codes. So they're 6 digits, 0077BB. And basically what this means is that, so for the first line that you plot, it'll choose this color. The second line, it'll choose this color. The third line, this color. Fourth, fifth, sixth, seventh. And then after the seventh one, it'll cycle back to this first color. So this will be your 8th, 9th, 10th, and so on. And that's what this cycler object does. Okay, so we can compile again, and you'll notice that the colors have changed to something a little bit different. Now, the final thing that I'm going to get on my high horse about here is that I don't like this little box around the legend. I think it's distracting and I don't think it adds anything. So you can quite easily remove that if you want to. Don't worry if you want to keep that. I think this one's more of a personal taste for me, but I'm just going to show you how to do that. Now, another reason for showing this is that I want to point out that there's many other things that you can do with a matplotlib style sheet to suit your tastes. And so it's worth reading through the documentation for doing that. And the nice thing about the style sheet is that it has nothing to do with your plotting script, right? So you can copy this style sheet around and reuse it in different places. And you don't have to remember what any of the commands are, and you don't have to use them again. Now, if we go back to the plotting script, right, it's just basic stuff, right? There's nothing in here about the styling of the plot. We don't need to remember that every time, as long as we keep this file around. So remove figure box, and to do that, not figure, legend box, and to remove the legend box, all we do is legend.frameon false. And I like to make the legend text a little bit smaller, dot font size, and I set that to 6. So let's compile it again. And you see that the frame has disappeared. And this is the plot that I showed you at the start of the video. And it's really very easy, right? It's just these lines. It's not even Python. It's just some names and some colons. I hope this has been helpful. Like I said, there'll be plenty of stuff in the description to help you out. I'll even put this whole style sheet in there for you, and you can just copy it and use it. Thanks very much for watching, and good luck.